Right, let's talk about the equations again. The category, like the types of questions that you get in your paper are usually you get overall equations. That means to write the equation. The normal equations you have to write when they give the either they give the reactants and ask you to write the products and the whole equation, or else they even tell that in a sentence, uh, the reactants and the products both, then you have to write the equation. There again, the main thing is you have to write the balance equation and the state symbols too, right? That's better to do that if you have 2 marks, right? In that question. The second category is ionic equations. You need to know how to write ionic equations also. Right now, many of the people have this problem, and it's even if you don't say there's no problem, actually I've seen in your papers there are issues, right? So ionic equation is an area that you have to work on a lot. Most of the people can tackle this one, right? If they can be careful, and this one, uh, like a little difficult for many people, right? So the third category is half equations. That's also ionic half equations. We can call them half equations are also there, right? That's the main 3 categories that you have in your syllabus. Except for this, sometimes you have them organic reactions. So there you have cracking equations. That's quite easy, right? Isn't it? And then there's another type of reaction. I mean, reaction involved question called why this reaction is a redox reaction. Like that, they ask a question. Why is this reaction a redox reaction? Or why is it a reduction reaction or oxidation reaction? You have to tell what's happening in that equation then. So let's look at them one by one, right? We can take questions and see itself. So I'm just going to take some questions and look at them. Let's take questions. When you see now the paper in the year is not mentioned here, but I see many questions with, oh, this one is good. This is just this recent paper, recent 2020, I think, right? Messaging like this, so the page comes like this. This is a question, only 1 mark. This came in the middle of a question paper, like full question, right? So I search like this, I make this bigger first of all, right? Okay, this part is not even relevant for our topic now. We're discussing only the equations now. So this is actually lead oxide reacts with concentrated hydrochloric acid to form lead fluoride. This is lead 4 they have mentioned here, see? Lead fluoride they have already given, and water, right? And then they ask construct the equation for this reaction. Now when you just see the word equation, this is an overall equation they're asking, right? It's only 1 mark. So they're only asking you to write the overall equation, right? Overall equation. If they want the ionic equation, they specify that, right? Let's go to our ionic equation in short while. They're starting with easiest, okay? This is like the lowest level or the easiest level. We'll start with this and see whether you can write this one. So here they have given the main thing that you should do is underline, right? This is the reaction, one of the reactions, right? The reaction. So lead 4 oxide with concentrated hydrochloric acid. Doesn't matter. Hydrochloric acid is there. That's the second reactant. Second reactant, right? And then you see it's forming, right? It is forming, or they're forming lead 4 chloride, right? It's already being given here. The formula is given here already, right? Lead 4 chloride and water, right? So it's easy. First of all, the best thing is like this. Now you're not taking this much of time to read this because I'm teaching you. I have to explain to you. I take time, right? But when you're reading this, like even if I just read it, I just have to read this very fast, isn't it? While reading this, you can underline it. Or while underlining it itself, you can, if you add the little level, lower level, if you're finding them difficult, at the beginning, the good practice is writing the formula here itself. You know what is that, right? What this is, or else you can write it here directly, right? That's fine. Lead 4 oxide. When you say lead 4, you know 4 is the oxidation number. So lead is 4, right? In the oxidation number, that means I'll write it somewhere here. Lead oxide, you write like this, right? So there's 2 oxygen. How does this come? If you have a question, that's your homework to do your crisscross, right? How to get the ion switch and get these kind of formulas correct. So if you have problem with the crisscross, you have to refer to that, right? I'll just do one for you here. lead and oxygen. We have the two ions here. Lead ion is an ionic compound. Yes, it's a metal and non-metal. That means ionic equation. Actually, ionic compound, right? So ionic compound means this is the positive ion, right? The metals form positive ion, and the negative ion is oxygen oxide here. So formed by oxygen. So what's charge? Lead is actually +4, and oxygen is usually oxide ion. Oxide ion's charge is -2. You should know that, right? You have to memorize it. So oxide ion, that means because it's in the 6th group, you have the reason like that, right? So it forms the -2. You can crisscross, and when you crisscross this, you get right. Color here, lead oxide, right? This is how you write lead oxide. So you can't mix up this, right? You can't write lead oxide as you wish here, and your answer is like done for. You're getting wrong answers. Just not, if you can't write the formulas properly, first of all, go to crisscross and sort that issue. Otherwise, no point of writing this anyways, right? But this 1 mark matters, you have to save your marks one by one. So let's write lead oxide first, and then we have this oxide is wrong. This is the correct one, right? Lead oxide 4, lead 4 oxide and hydrochloric acid. This, of course, everyone supposed to know the formula. Hydrochloric acid is HCl, just HCl. And then you get lead oxide, sorry, lead chloride, right? It's also lead 4 chloride, so that means lead chloride you write like this because lead is a +4 ion here, and chloride, -1 always, right? -1 and +4, so you get lead chloride like this, and therefore, and then you have to balance this. That's it. Are these difficult? No, these are normal overall equations. They're not usually difficult to write. Okay, so just balance it. We can put here, I think there's 2 chlorine atoms, so we put 2 here, maybe, right? Then we see where this balance. Yes, 2 hydrogen, 2 oxygen. Oh no, 2 oxygen and 1 oxygen here. So we have to change that first. First of all, make this oxygen balance. You can put 2 in front of that, right? And then you get what? Now 2 hydrogen. Okay, 4 hydrogen atoms, right? So we can put Cl, right? Only lead oxide, and the hydrochloric acid gives lead chloride. My number is wrong here. That was the case. I was telling it 4 and then wrote here as 2. Yeah, that's 4, right? Lead chloride is the 4th one, 4, so it's going to be PbACl4. My God, PbCl4. So now you can put actually 4 here and it will be balanced. Otherwise, it will not balance the one, right? Okay, so here it's 4 HCl, and we are getting 4 hydrogen atoms here, 2 times 2, and chlorine also 4, right? Here it's 5. Now lead 1 lead atom, 2 oxygen, balance, right? So it's a balance equation, not very difficult to balance if you write the correct formula. Like, don't make a mistake here with these numbers, right? Like, because usually we have practice of writing some numbers, but don't write them. Always follow the crisscross, the logic part. Okay? Right, now that was the first question I want to discuss here. It was the normal equation, overall equation. Let's take another one and see. It's also from the same paper, 2020. Take this one. Let's see, what does this say? Yeah, this is also just to make an ionic equation. No, just a normal equation. Look at this, right? Consider sulfuric acid oxidizes arsenic to arsenic 3 oxide. Whatever they say, it doesn't matter if they're asking only the equation. And in this case, actually, they don't even want you to write the substance. You can see that they have already written the substance. It's like the reactants and the products they have fully written. Only they want you to balance. Now this balances. So this type of questions are just asking you to balance it, right? There's a complete no, right? So balance it. Okay, we write here to how many answers? Okay, before going to that one, can we go to sulfur? Fine. Sulfur is 6, they say, right? You can see here 6 sulfur atoms, so you can take 6 in front of this because this sulfur should be multiplied by 6, and that's the only place we have sulfur in the among the reactants, right? So this should be multiplied by 6. And then we have arsenic maybe 4. We can try that too. Yeah, because it won't be affected by these ones. And how many water molecules? How many hydrogen molecules? How do you check that too? Because there's only hydrogen here on this compound. Sorry, among the reactants, only this compound contains hydrogen, and it contains 12 hydrogen atoms now. And here on the product side, only hydrogen is here, right? We find only hydrogen. We find our hydrogen only here, So that means if you multiply that also by 6, you get that balance, right? And then what you can go for arsenic. Arsenic is just 4, and there's no other place where you can have arsenic here. So it has to be multiplied by 4 in this particular case, right? And it's balanced, I think, already. Let's check that. 4 arsenic, 6 hydrogen, yes. 6 sulfur, 6 sulfur, yes. 6 times 4, that is 24. 24, right? 24 oxygen atoms, that's quite a lot. And then there's how many oxygen here? Sorry, 6 and 6, that's going to be 12. And again 12, 6 times 2, 12, 12, 12. It's 24, right? Okay, so that's balance, no? Okay, that was a little bit tough, like no big kind of balancing, no? So that's why they have given it 1 mark. Okay, so the next one. 3, this is this one. This is also about okay, now this type of questions, sometimes this is the same paper during I'm taking, right? So this type of questions, this is also equation. I just search like this. You also can search like this in your PDF. You can search just equation. You find all the equation questions, right? So this is actually from one paper I'm taking here. This is 2020, I think May, June, or October, November. I can't remember exactly that one. And then this was there either in 22 paper or 21 code, right? The code is yeah, I took all the codes, so there can be few questions here. Right, let's see carbon dioxide. This part is not necessary here. We need to write only this one. They're asking, use this equation to explain why the iron oxide is reduced here, right? That's 1 mark, yes, but the 1 mark matter, right? 1 mark matters. No? So the carbon monoxide reduces the iron trioxide in the iron ore. This is a reaction that happens in the iron ore, right? Iron extraction. So shall we tell why it is reduced here? Iron oxide contain what? If you see this compound, right? It's a compound, children. Can you see this contains 2 elements? So it's a compound, right? If it's a compound, in a compound, the atoms that are together should have, right? Then if it's an ionic compound, this should have been an ion, right? This iron and oxygen are ions here. This is not just atoms, right? They are ions. So we can write the ionic number here, right? This one has been an already ion. What is the ion present here? To identify the ion, you can break the compound into 2 like this, right? Or else you can use the backward crisscross to find out the ion. How do you use the backward crisscross here? Okay, I call it reverse crisscross or backward crisscross, right? This is the compound we have, and you know iron is coming from the left side, that is the metal ion, right? And oxygen should be coming from the right side, that's an ion or the negative ion, right? Let's take the numbers backward, right? These 2 must have come from here, right? Okay, and these 3 must have come from this. So this is a +3 ion, and this is the -2 ion. You know that, right? That's how we do it. I'm just showing you the backward crisscross, right? Very simply, I'm teaching this part because please don't make mistakes. Identify the ion properly, right? Right. This is iron 3 plus then. There are 2 atoms there, that doesn't matter. Now that is actually, it got these 2 ions, yeah, 2 ions from iron 3 plus ions, right? So this is actually iron 3 plus present here, and oxide 2 minus present here, right? Okay, right. Identify the ion. Now that ion, you can take some single ion and say what? These iron 3 plus ions have, what has happened to them? They have become iron the metal. When the iron the metal is there, that means alone element, right? Single elements, they have the oxidation number of 0, right? They don't have an ionic number because they are elements. They are elements, they don't have a charge, right? 0. So the iron 3 plus had become iron the metal, right? So what shall we say? What had happened here? Even if they say oxidizes or reduces here, oh yeah, this is actually iron is getting reduced, right? So reducing means, you know, in oil rig, you can use oil rig here. Oil rig says what? Oxidation is, what am I writing? Oxidation is loss of electrons, right? And reduction is gain of electrons now. Right now, reduction is gain. So here it's actually going to be reducing the iron oxide Carbon is reducing the iron oxide, so iron oxide, iron 3 plus ions. You can write like this, ions. Or you can say, we can even type a singular term that's even not confusing you, it's easy, right? So iron 3 plus iron, we have to mention that this is a particularly iron 2, okay? So iron 3 plus iron gains 3 electrons, you can be careful, 3 electrons, right? To form, go to this part, this is the answer test, right? To form iron metal. Or you can write solid here as a symbol if you just want to write the symbols, iron metal or iron metal atom. Right? The iron has gained the electrons to become atom. That's why we get it isolated, right? Who gave that electrons? That's actually carbon monoxide side. Okay, so just to write that is the answer for this. These type of questions are also very common. You will see a lot of questions like this, even the ones that I selected. I have many of them. We might come across some more. Let's see. That's the answer. Okay, so let's see another one. If you check in one paper, you won't get the same type of questions a lot, no, right? Yeah, different types of questions are getting. So here, this is also a construct the equation. For this equation, it's methanoic acid, right, and magnesium powder. Now, this is one of the organic acids, right? Organic acids with magnesium powder. Magnesium powder, when you say, you know, magnesium, the metal is there. This one, magnesium, the metal. So you need to write the equation for this one. Methanoic acid or whatever the acids, you know, that's hydrogen ion that is going out. Now, identify the ion that goes out in methanoic acid. Where is the hydrogen ion that goes out? This one, right? Whatever it is, one hydrogen has to go. Now, in the methanoic acid, the remaining part is what? The methanoid group. Let's break it down like that. Now, our anion will be what? The ions we have identified. This is the acid, right? If this is the acid, like our HCl can be, like, remember we break down HCl, right? I'll show first that one. HCl we can break down into 2 ions, right? H plus and Cl minus. Remember, right? You can do like that now. Ions breaking down, right? Similarly, we can break down even organic acids. We can break down. They might contain some bulky part here. That doesn't matter. You have one hydrogen that can go out. That is the acidic part, right? That's the acidic hydrogen ion. No, you can say acid ion or hydrogen ion. So let's break that down and see. This is HCO2 and this H. Actually, it gives, now this is not the reaction. I'm just showing you the ion, right? So here we get the anion is this one, HCO2 minus and hydrogen plus, right? These are ions present in this acid. So I'm just wrote like this. Actually, these are the 2 ions. You just have to know the ions here. These are the 2 ions. Then if you react it with magnesium powder, what happens? This anion will be combining with magnesium. Remember? You know, if HCl combines with magnesium, what happens? You get magnesium chloride, right? The chloride attaches to magnesium because magnesium is more active, right, than hydrogen. So magnesium chloride and hydrogen you get, right? Similarly, the product here also should be what? There should be hydrogen. Yes, and we should get, okay, the product, the whole reaction they are asking. You can take this anion, right? Isn't it? This is anion. Oh, wow. This is the anion, right? And that anion you have to combine with magnesium. So HCO2, magnesium. You know what happens with magnesium? Magnesium is a +2 ion. You take this minus ion with magnesium, what happens? This plus makes it double, right? Double of this ion. You have to get 2 of them. Right? 2 of them, and acid was actually, we can write the backward. I'm just writing the backward here. It doesn't matter. I wrote, okay, I'll write magnesium. It doesn't matter the order. Methanoic acid is HCO2H. The point is you have to identify the anion. So first of all, whenever you get an acid, any acid, break down the ion and hydrogen ion and see, right? Hydrogen ions and see. Now, in this case, in the metonic case, you can break it down like this. This is an ion. Identify that anion and then take that one with whatever the metal they give. If it's magnesium, you can do the crisscross part and see as well. This is magnesium 2 plus, no, right? And it's CO2 minus ion, right? You crisscross and find the compound. You can write like this also, that doesn't matter for like organic ions. You can write the anion first and the metal ion second. That's how they usually have it in the writing. We write like that, so write it that way, right? Magnesium you can write as a second part. Okay, I gave this as a supporting part. That is not the reaction actually. Okay, that's how to identify the ion. I talk about it again, right? We have to take this acid, break it down into two ions. The hydrogen ion, especially separate this hydrogen ion. Then you will see that it is hydrogen plus, right? If this is hydrogen plus, this is going to be minus, right? This sign is minus and this is hydrogen plus, okay? So the two ions you have to consider and consider it as HCl and try to write your reaction with just HCl and you know the products, right? Acid with metals, you get hydrogen and the salt. How to write the salt is the bigger job, like big job here, right? You have to be careful and crisscross it and write, like magnesium 2 plus and HCO2 minus, right? Yeah, just crisscross this so you get 2 times, get it like this also, either this way, 2 times this. Right? Like that now? Okay. Now, identify the ion, negative ions here present in the case of acids and stuff, right? You should underline these words like the acid and base. But wait, sorry, acid and metal here. That's why we wrote the products like this. First of all, derive the product and then write the salt properly. Okay, in that case, when you get acid-base reactions. Anyway, the reactions you should know the the products, right? Those products you have to write in the symbols. That's it. And balance it. Oh, in the previous one, you should balance it as well, right? Okay. The balance part, I think. Sorry, because here there's 1 mark, still you have to balance it. So let's write again and balance it. That's magnesium, CO2, H, and gives what? HCO2 twice with magnesium and hydrogen. For the balance is, you see there's 2 HCO2. So we need to put 2 in front of this, right? Then acid, that means this acid, and this one is balanced. Check that out again. Magnesium, 2 hydrogen, and 1 more. So 2 times 2, this means 4, right? 4 hydrogen. Here 2 times 2, 4, 2 times 2 is 2. So 2 times 1, and then 2, that's going to be 4. And there's oxygen, 2 times 2, 4. Here 2 times oxygen 2, right? 2 times 2, that's 4. That's balanced. Carbon 2 and carbon 2, yeah? I have told you the tip also when you're writing acids, organic acids with metals, so bases, you can think of this organic acid. If you want to easily balance that, you can assume this as HCl, right? And write the reaction with that and see how it balances. It is the same way that it balances with any organic acid, right? So you can do that, right? What about the consider it as HCl and write to see the balance equations. Okay, that's easy, quite. Right, next one, let's also write about the oh, that's collation story, so I'm not talking about that. That's theory partner. Right. What about the next one? Please see next question. It's a cracking question, it seems. That's very easy. These are all in the same paper. Okay, you're getting many marks, like about maybe 3, 4, 5 marks, right? Or maybe 3 to, like most the average, at least you get 4 marks, 5 marks from just balancing equations. So you can get these marks by writing equations from the paper, from the theory paper, right? So that's 4 to 5 marks sometimes. But these 4 to 5 marks, more also I have told about 8 to 10 marks most, right? From the theory paper. So that's how the marks are adding up. So you all tell this is the most difficult area, and then you all don't do that, and then you say always you put the blame on this. But the point is you are lacking marks from theory. Sometimes we can't avoid that. You lose marks from theory parts, like you forget areas to write and that kind of stuff. And almost maybe you don't write the exact way of answer, like exact thing, so you don't get the full marks. Like that kind of things, it's hard to avoid. So, right, know it properly here also, right? The equations. These equations you can't make mistakes. These are very easy ones. Okay. Only ionic equations are a bit difficult, you can say. Others actually not is difficult, right? Complete the equation for cracking tridecane, that's okay. That's 13, carbon 13, and an alkane, and to form propane and one other hydrocarbon. Let's say now they're saying this, you need to underline this. This is tridecane, yes, that is there. We should read this very fast, but you have to just see this. It's present there, right? Propane is there, yes, we can see propane, and one other hydrocarbon. So hydrocarbon only they didn't say it's an alkane, they didn't say it's an alkene, but you know there's only one other. That one word is important here, means there's only one other element. That means we need to put this remaining atoms here to make it up, or to make the compound. Let's see what, like, if you subtract this, what kind of compound we get. Here 13 carbon atoms are there and 3 go on here, so we need to get C10, right? The remaining part, remaining 10 atoms come here, carbon 10. Then 28 hydrogen atoms are there, 6 have gone to propane, and therefore we should have how many hydrogen atoms? 22, right? Yes, it seems like a what? It's an alkane, right? You can write like this. Or sometimes there are people, like some write the multiply, that means the balance equations with numbers that can be like higher numbers, and you write it is balanced with, to balance it, you write another number. Like that kind of option sometimes possible. But my suggestion is always write this one. Easy. Subtract and write the number of atoms. Okay, number of atoms present, right? That's easy. Okay. Then there's another one, easy. Right. I see equations are not always difficult, because so far we only came across overall equations, isn't it? That was just one paper. I can take a paper and show you as well. To save your time, I actually took this screenshot separately. Okay, look at this now. Again, normal equation they are. When lithium reacts with water, aqueous lithium hydroxide, LiOH, and hydrogen, they have even given LiOH. See how good these examiners are. Oh, sorry. The exam, okay, the paper who's like, what we know, the, yeah, we can call them examiners, okay. All right. See, okay, now hydrogen here, we have hydrogen, and here we have lithium and water, okay. So you try just very simple equation, Li plus water, H2O. You can write here itself if you want, right? Then LiOH, okay, and then hydrogen. And then most specifically, you can't just write it like this and leave it like just thinking it's just one mark. No, right? You have to balance it. Whenever you write reactions, it should be balanced. Without balancing, equations are useless. That's right? So write it, balance it. You can see if you write it, balance it. Yeah, isn't it? Right now here we have hydrogen and oxygen. There's problem here with hydrogen number. Look at this hydrogen. There's one here, two here. That's like an odd number and an even number. And on the left side, you have an even number. So if you multiply this by any number, you get an even number. And on this side, if you, yeah, you have to balance this one with the odd number, right? Odd number hydrogen should be first of all made into an even number. The smallest even number that we can multiply this with is 2, right? Put 2 in front of that and balance this. Make this a 2 hydrogen, and now get what? 2 hydrogen and 2 hydrogen here, and 2 oxygen. That means if you put 2 in front of water, you get 4 hydrogen atoms and 2 oxygen atoms too, right? Now here we have 4 hydrogen atoms and 2 oxygen atoms balance. What about lithium? Lithium 2 atoms. So we have like 2 lithium atoms here. That's it, right? But my suggestion is writing even the state symbols if you can. This is solid. This is liquid, or sorry, liquid L. That's liquid, and this is aqueous, and this is the gas at room temperature, right? So writing the state symbols is also good practice, because you're not trying to lose marks like that. You will only save your marks if you do that. Okay, next one. Okay, now we are coming to Ionic, isn't it? Finally. It's the first one, right? You think it is. It's not that difficult. Let's see. The ink, I have to see that. Where's that classy there? Okay, right. Oh, they're asking you to write the Ionic equation. Yes. The ink darkens when what? When used on paper. I even didn't take the previous part of the question because don't send messages there. It's being recorded, yeah. Okay. You can send it. Is that a question for me? I'm not going to open the chat because it is being recorded. Okay, right. The ink darkens when used on paper. That doesn't matter. You don't even need the first part. So just here, actually, it doesn't matter. So you can read this part and see that just to write the Ionic equation they ask you, right? The Ionic equation, and this is because two ions are oxidized to three ions. This is very simple, isn't it? You don't have any other details. So what does this mean? They only want you to write the half equation. But the point is, they have not even specified and asked you to, they have not told that you need to write the Ionic half equation specifically. They have not mentioned half. But the meaning is you have to write the Ionic half equation. Why half? Because the rest of the thing that happens, we don't even know, right? What's happened to the other element? What's happened to the other substance? We don't even know that. I'm not taking that part even. That's not necessary here. Because this question is about this one, right? What happens when iron 2 plus becomes iron 3 plus? That's it. That's it, right? Okay, so iron 2 plus is this one. You know, right? Now write iron 2 plus, Fe2 plus, right? The Fe2 plus has to become Fe3 plus, isn't it? This is 3. Fe3 plus. Now, Fe2 plus becomes Fe3 plus when it loses electrons. Losing means electron should be on the right side, the product side, right? Fe2 plus became, we call it like that, no, Fe2 plus became Fe3 plus and an electron. That's the product. These are the two products, Fe3 plus and electron. Or you can say, lost electron should be shown on the right side as a product. This is lost. So show it as a product, right? From this guy, from this one, it was lost. So you show it on the right side, product side. And sometimes children write, like, just know, we have seen this, like, very pity to see this kind of things, right? Sometimes some of you write iron 2 plus gain electron and write iron 3 plus. This kind of like nonsensical things you write. Nonsensical, right? What was the meaning of electron? You know, electrons stand for a minus charge. If a minus charge is added to a positive ion, right? Positive ion means it has lost the electron, so that's why it's positive, right? If a positive ion gains an electron, it can never become further positive. It becomes, then it becomes less positive, right? Either it becomes less positive, it becomes an atom. Now you have to join back again. And one more thing I have to tell here, when you're writing electrons, children, be careful here. There's a small thing you have to add. You put a minus sign here, right? To show that electron. E minus 1, okay? So that stands for a minus charge, 1 minus charge, okay? Right here, Fe2 plus become Fe3 plus and electron is lost. That's it for this equation, Ionic. We have some more Ionic equations. Join in the next session, okay? Right. We'll take Ionic equations more and see, and the tips are also given at the end, okay? Right.